Okay. So in the yesterday lecture, basically we have seen that about positive displacement pump. So in that we have seen the important points are there is fluctuating flow rate. Okay. So we can reduce it by many ways. Second, they are self-priming. Okay, we will see what is priming today in detail. Third, we have seen that it will be used where we want very high pressure fluid. Okay, high pressure fluid. Okay, the application where we want a very high pressure fluid, it will be used there. Fourth one, it is known as constant volume pump. Okay, okay, it is known as constant volume pump. Okay, and fifth one, basically fluctuating flow rate, self-priming, high pressure fluid, constant volume pump. And fifth one is basically it is used in most of the time in packed bed and dosing. Okay, packed bed and dosing. It is used there. Okay, so these are the 5 important points. Okay, which we have seen for that. Okay, self-priming. So this self-priming, what is priming and all that today we are going to see. Okay, we will see in detail. Then this is high pressure fluid and constant volume pump and packed bed and dosing. Okay, so these are the things which we are done in the yesterday class. So we have seen that how it is useful. Okay, because it creates so much pressure in that. Okay, so this all I am talking about the, and the one most important thing we have seen for this is Q actual is greater than Q theoretical. Okay, so that is why efficiency wise it can be good, but there are certain things we have to maintain, that it should be at high rpm. Okay, high rpm. Okay, dia more suction line. Okay, so this we have to see, because basically inertia will help this. Okay, inertia or momentum you can say will help to achieve the Q actual greater than Q theoretical. Okay, so I told in chemical industry we will be using almost 10% of this pump, that is positive displacement pump. And so there are various types of positive displacement pump also. First, it is divided into reciprocating pump and rotary pump, so that you will see in the fluid mechanics. Okay. Next, we are going to see. Okay. Next, we are going to see today is centrifugal pump. So here, who is responsible for creating a pressure drop? You can say torque. Okay, torque is generated here. So basically, in the yesterday last class, I have told that pumps are good. Pumps are good liquid pusher. Okay, they will push the liquid very good in comparison to the pull. They find it very difficult to pull the liquid, so that is why they have a certain limitation while pulling. Okay, that is very important. Okay, they have certain limitations while pulling the system. Okay, so that we are going to see today, what are the different limitation and all that. So first, I will tell you about the this centrifugal pump, how it works, the basic like this. Suppose this is okay, it will be like this. Okay, so it is impeller is like this. Then at center, it is connected like this. Okay, so here, so from this section we consider it as HS. HS means suction height. Okay, and it is going to somewhere else, or you can say like this. Okay, some, so this will be HD. Okay, so we will be more interested in HS. Okay, so by seeing the position of this impeller, can you tell me that where it will be moving. It will be moving clockwise or anti-clockwise. This is the position of impeller. Okay, can you tell me where it is moving? It is moving in clockwise or anti-clockwise direction. Okay, this is the impeller. Okay, some are writing clockwise, some are writing anti-clockwise. So just think I'm giving you 1 minute. Okay, tell me that where it will be good. Moving this impeller with a clockwise or moving this impeller with a anti-clockwise. So it is better to move this in the anti-clockwise direction. I will explain you why. Anti-clockwise direction. See here. When the fluid is moving, okay, when the fluid is moving, suppose the fluid particles are here. So what will happen? Due to this, what will happen if the it is moving in clockwise direction? It means in this direction, so the fluid particles will stay there. Okay, so they may create some pressure on these blades. Okay, due to that, there may be the chances of the breaking of the blades. Okay, but if it is moving anti-clockwise direction, just see the fluid particles will be here. Okay, the fluid particles will be here. So in this case there are very less chances, physical damage of you can say blades will be less. Okay, so that is why in this case it will be moving in the, okay, it will be moving in the anti-clockwise direction. Okay, it will be moving in the anti-clockwise direction. Why? Because if it is moving in the, see, suppose this is blade. Okay, so this is blade. Okay, and if it is moving in the clockwise direction, what will be the fluid particles will stay here. Okay, so due to torque generation and all that, there may be chances that it can break. Okay, it can break from here. Okay, due to extra load. Okay, but if the fluid particles are here, okay, there is no chances of breaking here. Okay, the mechanical strength will be high. So that is why you can say, okay, that is why it will be, it will be anti-clockwise direction. Okay, it will be anti-clockwise direction. Okay, everyone got this point? Okay, so this is you can say interview question in which they ask that by giving the this plates how it is moving, whether it is moving in clockwise direction or whether it is moving in
Hello.
anti-clockwise direction. Okay, so hope you have found it useful. Okay. Okay, now see here that basically what will happen here, HS is suction height. Okay, here SS is suction height and here SD is delivery height. Okay, so everyone got this point of clockwise and anti-clockwise. So such small things we are going to see in today's class, that how it helps while designing the pump. Okay, not numerical type. Okay, we are not going to solve a numerical types. I am just asking a theoretical questions on the pump. Okay, numerical you can see on the fluid mechanics subject. Okay, so basically now you have seen that it is suction height and it is delivery height. Now the pump is moving. Now what is happening here is that basically here, here the suppose this is a storage. Okay, so suppose this is a water storage. Okay, so here this should be a wide opener. Okay, this should be a wide opening like this, and here it is a strainer. It is just like chunni. Okay, just like chunni, so that dirt particles will be removed from here. Okay, so thus water will go from here, so that dirt particles will be removed. It is just like a screening. Okay, so what will happen if you want to see a basic centrifugal pump, then what you can do is in your home that if you make a lemon juice. Okay, so if you have observed clearly how the lemon juice you make, okay, so how you make, you take a glass of water. Okay, you take a glass of water, in that you have taken some amount of salt, some amount of sugar, and lemon. Okay, then you have a spoon. What you will do, you will place that spoon at the center, and you will just rotate your hand at a certain rpm. Okay, so what you will observe there, okay, you can do this and at your home also. What you will observe that water will move. Okay, the water will move away from the center and towards the periphery of casing. Okay, in that casing is the glass. Okay, so you will observe, what you will observe, the water will move away from the center and towards the periphery of your wall. So same thing will happen here also. Okay, same thing will happen here also. When you are saying that the water is moving away from the center and towards the wall, actually what is happening at the center? What is happening at the center? At the center, you can say that there is no water available. So for better rpm, you can see that you can use your home mixer. Okay, you can use your mixer in that, in your home. If you are making using a mixer, you can just watch, it is a transparent. Okay, you can watch there. So what it will happen in your mixer, the moment you start your mixer, the particles will move away from the center and towards the wall of your that body. Okay, so it means at center there is nothing. Okay, it means at center there is nothing, because that is a packed body. Okay, that is a closed body. It means there is nothing. What is there? What is technically, what is there? If no thing is present, what we say in for chemical engineers, what is there? If no matter is available there, that is known as vacuum. Very good. Okay, that is known as vacuum, is known as. Okay, so that is why their vacuum is created. I'm not saying that is 100% vacuum. Okay, I'm not saying it. Okay, for 100% vacuum, that object should be 100% sealed and all that. Okay, but I'm saying that some vacuum is created there. Okay, some vacuum is created there. So same thing will happen here. The moment the impeller will rotate, the moment the impeller will rotate, there will be the some vacuum will be created at the center. Okay, there will be the some vacuum will be created at the center. So here at bottom, what is the pressure of that water? What is the pressure of that water? Here at the bottom, what is the pressure of that water? Tell me. atm. Okay, that is 1 atm. Okay, very good. Here at bottom, the pressure of the water is 1 atm. Okay, here at bottom, the pressure of the this water is the 1 atm. Okay, and here what is the now pressure due to the rotation? What is the pressure at center? It is vacuum. Okay, it is vacuum. So here you are in the 1 atm. Okay, I'm just saying about the groundwater. Okay, it can be more than that. I'm just assuming it as a atmospheric pressure. So here see, it is 1 atm, this is vacuum. So which one is greater? Which one is greater? Which one is greater? Obviously 1 atm is greater. Vacuum, what is vacuum? Which is lower than the atmospheric pressure. So what is the direction of a flow then? Tell me. Then what is the direction of a flow? It will be in the this side. Okay, from higher pressure to lower pressure. So that you have studied well in the fluid mechanics subject, that the fluid will, okay, the fluid will travel. Okay, the fluid will travel. Okay, the fluid will travel from a higher pressure to lower pressure object. Okay, so here what is the fluid will travel from higher to lower. So what is higher here? 1 atm. What is lower there? Vacuum. Okay, so that is why you can say that in this way the fluid will move in the pump. Okay, Okay, so this is the thing that how the fluid moves in the centrifugal pump. So that blades will generate a torque, and what it will then the fluid, once the fluid reaches the center, what will happen? This impeller is continuously moving. It means the fluid will move away from the center. So now see, the fluid will move from away from the center and towards the periphery of wall. So what it will do? Okay, so Lord, okay, what it will do? Okay, what it will do? Then it will generate at the outer, it will generate again a high pressure. Okay, again there is only one outlet for here. In this way the fluid will go up. Okay, the fluid will go up to your delivery height. Okay, the fluid will go up to the delivery height. Okay, means there you can say the section is divided into two parts. First, one ATM to vacuum, then this impeller will create a high pressure. Okay, this impeller will create a high pressure at the this tip. This tip of impeller will create a high pressure. So again the fluid will move from the outer section and from high pressure to lower pressure. Means in the pump there is vacuum is also creating at the same time. At the center there is a vacuum. At the outer side, what is there? At the outer side there is a very high pressure. Okay, there is a very high pressure. So that is the use of the pump. So we generally create a high pressure in that system. Okay, okay, everyone got this point? Wait a second. Wait a second. Okay, 1 second. Okay, wait. Okay, am I audible? Screen is visible? Okay, so at center there is a uh, there is a vacuum in the system. Okay, and you can say at center why there is a vacuum is created because centrifugal force is there. Okay, you can say by the impeller centrifugal force is created in the system. Okay, so due to that what will happen, the fluid will move, okay, inside the impeller, and once it get outside it will be at the very high pressure. So from again the fluid will move from higher pressure to lower pressure, because what is happening here, when the fluid is moving here, velocity is increasing. Okay, v1 square by 2g is increasing. So when velocity increases, P1 by rho g decreases. Okay, so we know that it is inversely proportional. When velocity increases, pressure decreases. Okay, so this can be easily proved by the Bernoulli's equation. So this you can see in the fluid mechanics. Okay, the relation between the V1 and P1. Okay, so I hope you are done with the Bernoulli's or not. No. Okay, okay. Then you can see. Okay, in Bernoulli's you will do this. Okay, V1 square and P1 you will go see the ratio. Okay. So now what I have told that centrifugal pumps are good pusher. Okay, so there is a difficulty in pulling. So what is this ATM pressure? 1 ATM. Okay. So if I calculate the value of P ATM equals to P by rho G. So what is P 1 ATM in Pascal? 10 to the power 5 upon, suppose I am taking water, into G 9.8. How much it is coming? Tell me. What is the value it is coming? What is the value coming? Okay, you are not done with the Bernoulli. So which topping is going on in FM now? Manometer. Okay, fine, fine. Means you are quite lot away from the Bernoullis. Okay, fine. So see here, it is 10.2. Okay, so how many hours you have done with this fluid mechanics? How many hours? 14 hours. Okay, 16. Okay, it's okay. 14, 16 hours. Okay. Still, you are not. Okay, okay. Means you are going with the basics. Okay, fine. So fluid. Okay, okay. 3 hours for surface tension. Okay, that's good. Actually, means you are going with us with basics and all that. Okay. Okay, fine. So see here, what it is coming, 10.2 meter. Okay, so 50 lectures means 100 hour. Okay. Everyone getting the answer, 10.2 meter? Okay, fine. So what it gives us the idea? Can anybody tell me? Can anybody tell me that what it gives us the idea 10.2 meter? Just think, 1 minute I am giving. Okay, just think. I'm going to tell you that point which you have not heard anywhere. Just think 1 minute. Okay. It means only I think one or two students have given the correct answer, that maximum suction head equals to 10.2 meter. Maximum suction head equals to 10.2 meter for any centrifugal pump in the world. For any centrifugal pump in the world, I am saying, okay, it is the maximum. Means this suction height means the height from the source of water, okay, source of water to the fluid. Yes, I have this 10.2 meter is water. Okay, if the fluid will change, then this height will change, because we are taking the density of water. Okay, so it gives us idea that maximum suction head for any centrifugal pump in the world is 10.2 meter for water. Okay, so we means 90% we are dealing with the water. Okay, so see this means if you go beyond that height 10.2, your pump will fail. Okay, and this is okay. Okay, and this is also ideal condition. This 10.2 meter is ideal. Why? Because we have not considered any friction or any other thing. Okay, this 10.2 meter is ideal. In reality, okay, in reality, it is okay, it is approximately 10.2 minus 2.7. How much it is coming? Calculate. 10.2 minus 2.7. I think approximately 7.3. 7.5 meter. Okay, so in reality, in real world, okay, in real world 10.2 minus 2.7, it will be 7.5 meter. Means suppose this is your pump. Okay, suppose this is your pump. Okay, what will happen? Suppose this is your ground source of water. Okay, so this height can be, in reality, can be 7.5 meter. In reality 2.7 I have taken losses. Okay, 2.7 I have taken losses. Okay, frictional losses. And you can't create 100% vacuum. Okay, to 10, when it will be 10.2, when it will be zero pressure here. Okay, so it is very difficult to create a vacuum here, zero. Okay, almost it is created in the terms of 2.6 to 2.7. Okay, because after that the water will evaporate. Okay, so this is the thing, that you can only pull the water from okay, you can pull the water only from 7.5 meter. Okay, you can pull the water only from 7.5 meter of water. Okay, now the second question arises, if it is the height of only 7.5 meter, then which pump, which pump, okay, then which pump is used in, then which pump is used in your tube well and bore well, or you can say well, okay, normal well. ओके कुएं या फिर बोरिंग में कौन सा पंप यूज किया जाता है, बिकॉज देयर हाइट इज, ओके, देयर हाइट इज, ओके, देयर हाइट इज हाउ मच, अप्रोक्सीमेटली हाउ मच, 7.5 मीटर को फीट में कन्वर्ट करो, कन्वर्जन ऑफ 7.5 मीटर टू फीट, ओके, convert 7.5 meter into feet, how much it is coming? I think approximately 28 feet, I think. Convert it. 24.6. Okay, 24.6. Very good. Feet. So what is the average depth of tube well or well? What is the average depth of tube well or well? I hope you know, because it is in current scenario, it is in every home. Okay. Yeah, it is in the range of 100 feet. Okay, it may go beyond from 50 to 200 you can take. Okay, 50 to 200 you can take. So that is the, means your pump is working at only 24.6 feet and you want 100 feet. So which type of that pump is? That pump is also a centrifugal pump. Okay, you can't use a reciprocating pump there. Okay. Okay, so that is a centrifugal pump. Okay, and now it is currently replaced by submersible pump. Okay, now it is currently replaced by submersible pump. Okay, so I will explain you that what is the benefit of using submersible pump. But the submersible pump is introduced in the market, you can say 10 years back. Before that, we are using a centrifugal pump, and there is a special type of centrifugal pump which is known as jet pump. Okay, there is a special type of centrifugal pump which is known as jet pump. Okay, everyone got this point? Everyone got this point or not? This is a very important point. Okay, means limitation is only 7.5 meter, you can say real life, and in ideal life it is 10.3 meter for water. Okay, so everyone got this point, yes or no? Yeah, I will explain that how it works. Okay, okay, once again I will repeat. Okay, suppose this is your centrifugal pump. Okay, this is your suction pipe, and this is your water body. So what I am telling is, here the pressure is 1 atm, everybody knows. Okay, so just convert that pressure into the meter. Okay, you can convert the pressure into meter, so it will be P by rho g. Okay, P by rho g. So how much it is coming? Tell me. For water. Okay, we are doing all the calculations for water, remember it. Okay, we are doing all the calculation for water. So it will be 10 to the power 5 upon 1000 into 9.8. So it is coming 10.2 meter of water. Okay, so here anyone has doubt? So it means how much it is pressure here? 10.2 meter of water. Okay, 10.2 meter of water. Anyone has doubt here up to this point? No. Okay, fine. Now we have seen that when the pump will rotate at the center, the value should be greater than 10.2 or less than 10.2. Okay, for the fluid to move here, The value should be greater than 10.2 or less than 10.2. It will be less. Very good. Okay, it will be less. Okay, so it can be suppose here it is 8 meter. Suppose I take here the value P1. Okay, so P1 by rho g is coming 8 meter. Suppose, okay, the pressure is 8 meter. So what it gives the idea? What it gives the idea? What it gives the idea? That what will be the value of suction head then? What will be the value of suction head then? It will be 10.2 minus 8. It is only coming 2.3 meter. Okay, sorry, 2.2. Yeah. Okay, 2.2 meter it is coming, means suction head will be only 2.2. So what I am saying that it can be different value 8 meter, 6 meter, but I am saying that the lowest value which you can go up to P1 by rho g equals to is 2.3 meter of H2O. This is the lowest value. Okay, lowest. This is the lowest vacuum you can create in the centrifugal pump, because after this the water will evaporate. Okay, this is the vapor pressure of your water. After this water will evaporate. Okay, so how much it is coming then? HS equals to 10.2 minus 2.3. कितना आ रहा है आंसर बताओ? How much answer is coming? 7.9. Okay, so these are just approximate values. Okay, these are just approximate values. Okay, okay, these are just approximate values I am saying. Okay, so it can be 7.4, 7.5. Just because I'm calculating the losses. Okay, so it means that this is the least value you can go. Okay, this is the least value. So means in real life, the height cannot be more than 7.9 meter. Okay, in ideal case, what is the ideal case? 10.2. Okay, and in real case, it will be 7.9 meter of H2O. Remember this word H2O. Okay, if it is mercury, then it will be different. Okay, so what is this? This is the suction height. Okay, what is suction height? Suppose this is your pump and this is your water body. So this is suction height. This is suction height. Okay, so this is cannot be more than 7 point, what we have calculated, 7.9 meter. Okay, so depending on losses, it can be 7.2, 7.5. It's okay. Okay, some in points it can vary. I'm just telling, in ideal case it will be 10.2. Okay, so this is like this. Okay, this will go from here. Okay, and the water body is here. Okay, like this, and with suction height we take from the ground surface. Okay, from the ground surface. Okay, from where the water body starts, there we consider the height. Okay, actually in real life it is from the bottom. Okay, but because the water level will keep on changing, so that is why fixed we take it from here. Okay, so that is HS. Okay, now everyone got the point? Yeah, suction height is from surface to the eye of impeller. Yeah. Okay, we will be only talking about the suction. I'm not talking about any delivery point. Okay, all the things I'm talking about the suction point of view. Okay, I'm not talking about delivery. Okay, so just write these points. Just write these points. Okay, I'm talking about suction height. Okay, I'm just talking about the suction height. Harikeshav, I asked because you said total height of bore will be 100 feet, where ideal it is 22.8 feet. Then delivery will be higher or not, that is why. You wait for that point, okay, Harikeshav? No, Akbarwa Chaudhary, evaporation is not good in pump. Okay, so that is we are going to see. So everyone got this point? Ideal 10.3 or 10.2? Everyone got this point? Ideal 10.2 meter? This question can be asked in the interview. Okay, what is the limitation at the suction height? So answer is 10.3. Don't worry about that minus which I am doing the losses. Okay, because ideal, at least you should know the ideal. Okay. Okay, everyone is fine. Okay. Now the question is, whenever the fluid will move, okay, whenever the fluid will move, your suction pressure should always greater than vapor pressure of your fluid. Okay, your suction pressure should always be greater than vapor pressure of your fluid. What will happen? Tell me. What will happen if vapor pressure is more? Tell me. What will happen if vapor pressure is more? Boiling. Very good. Okay, boiling will happen. So what will happen if boiling will happen? Bubble formation. Very good. Bubble formation. So what will happen if the bubble formation will happen? What will happen if bubble formation will happen? Cavitation will occur. And what will happen if cavitation will occur? See, here your pump is moving, your impeller is moving at a very high speed. So this bubbles, okay, so this bubbles at a very high pressure will strike to the impeller. Okay, this bubbles will strike to the impeller. So when they will strike to the impeller, what will happen? What will happen? First erosion will take place. First erosion will take place and corrosion will take place. Okay, first erosion will take place and then corrosion will take place. Okay, and that will decrease the decrease the life of your pump, and that will decrease the life of your pump. Okay, because they will strike, the bubbles will strike with the impeller. So why this is happening? When the vapor pressure of your fluid will increase. When it will happen? When it will happen? When vapor pressure will exceed your suction pressure. Okay, and once there is a air in your pump, okay, once there is a air in your pump, then what will happen? After some time, the impeller will not able to, okay, the impeller will not able to move the water. Okay, the impeller will not able to move the water, and what will happen? Your pump will can't deliver the fluid. And this happens in your home also. Okay, sometimes it happens that you have seen in your home also, you put on your that pump, still the water is not coming at the outlet, because what happened at that time, the suction pressure is less than the vapor pressure. Okay, please write that suction pressure, okay, will be less than vapor pressure, means the pump will not working at that point. So what you do, basically you just open a one nut in the pump, you again fill the water in the pump. Okay, you put a lot of amount of water in the pump and again start the pump and it starts working. So what is the process which you are doing it? Okay, what is the process you are doing it? You are filling the pump with the water. Okay, and then again you are starting. This is known as priming. Okay, this is known as priming of pump. Okay, this is known as priming of the pump. Okay, this is known as priming of the pump. Okay, so why this happens? Can anybody tell me why this is happening, priming of the pump? Because of the wrong selection of the suction head. Okay, because of the wrong selection of this HS value, because of the wrong selection of the HS value. Okay, and to select a correct value, we say that we have to calculate the, okay, then we have to calculate the NPSH, which is known as net positive suction head. See, word is coming suction head. It means this is only for the suction. We are not talking about the, we are not talking about the delivery. We are only talking about the suction. Okay, this is very important point. Okay, we are just dealing with the suction part of your pump. We are not dealing with the delivery point of your pump, because what will happen, okay, what will happen, see, once the water is reached to the pump, okay, once the water will reach to the pump, that impeller has a capability that it can move water to the any height of the building. It can move water to any height of the building. Okay, there is no limitation. The limitation is only in the suction part. There is no limitation on the outer part. Obviously, depending upon the size, depending upon the RPM, there are limitation. Okay, but in the suction there is a limitation. Even though if you bring a largest pump of the world, centrifugal pump, the limitation is 10.3 meter ideally. Okay, 10.3 meter of water. This limitation is not in the delivery head. Okay, this limitation is not in the delivery head. This limitation is not in the delivery head. So that is why NPSH. Okay. So what is the actual meaning of NPSH is pressure head at impeller, okay, minus vapor pressure head, minus vapor pressure head plus velocity head. Okay, plus velocity head. Okay, so this is happening there. Boiling will happen, bubble formation will happen, cavitation will happen. When the cavitation will happen, you will see that crackling sound will come in the system. Okay, crackling sound will be coming. Okay, when the crackling sound is coming, it means that air is going into your pump. The mixture of air and water is going in the pump. Due to this, what will happen after some time, that blades will be damaged and your pump will be destroyed. Okay, so that is why we should always avoid the formation of cavitation. Okay, so you can write these points actually. Okay, okay, you can write this point. Okay, it will decrease the life of your pump, and that is the priming of. Okay, so what is priming basically? When your vapor pressure is more than the suction pressure of your fluid, the fluid will boil. Once the fluid will boil, there will be the formation of vapors or bubbles, you can say. That bubbles will go and strike with the impeller. When they will strike with the impeller, crackling sound will come and they will first erode the impeller, and then after that they will corrode your impeller. Okay, and after that what will happen, that pump will be not able to throw the fluid. Okay, so after some time your pump will stop working. So what you have to do at that time is you have to just open a one nut and you have to fill the whole suction head. Okay, you have to fill your whole suction pipe again with the water. So why we are filling again with the water? We are just removing the air in your suction head, and then we will again start the pump and it will start working. Okay. So NPSH. So what is NPSH? That is the pressure head at impeller, vapor pressure and plus velocity head. Okay, so this is very much important. Okay. So you will see in detail NPSH in fluid mechanics also. Okay, in fluid mechanics also you will see in detail what does this actually NPSH means. Okay. So NPSH will gives you idea. Okay, NPSH will NPSH is basically P ATM by rho g minus PV by rho g minus, okay, minus suction head minus HFS, okay, minus HFS. Okay, so this is the NPSH available. Okay, this is the NPSH available. There is one more NPSH that is required. Okay, required. It will be given by the company. It will be given by the company. Okay, so that is why if see here in this formula, if your vapor pressure is exceeding, it means the NPSH will coming negative. So this value should always be positive. Okay, HS is suction head. So if you see your NPSH will increase. Okay, so if you have to select a pump, two pumps so of same power, then which pump you will select, which one has greater NPSH. Okay, so if you see HS, this is suction head. So for this pump, which pump? Submersible pump, this HS value is 0. Okay, so that is why it will increase your system. That is why I have given an example. Okay, HFS is friction. Okay, so that you will see in fluid mechanics. Okay, it is friction. Okay, if it is completed in fluid mechanics, then I can also go in so much detail, but you will be new to this term friction, so that is why I'm stopping there. Okay, so see here, I have given one example yesterday. Okay, suppose this is a storage tank and you have three options like this. So which one you will choose? Okay, so I have told 1, 2, 3. So which one you will choose? Okay. Okay, so the best one will be third. Okay, best one will be third. Why? Because for this HS equals to 0. So your NPSH will increase and it is good. It is good to have a greater NPSH. Okay, it is good to have a greater NPSH. Okay, it is good to have a greater NPSH. Priming is basically just filling your system again with the water. Filling the, you can write that priming means filling your suction pipe with the water or any fluid. Okay. And cavitation is the formation of bubbles. Okay. Cavitation means on the formation of bubbles. Okay. Formation of bubbles. So see here, why we are calculating the NPSH? Because NPSH gives us the idea. Okay, NPSH gives us the idea that your waves, that suction pressure, okay, this is your suction pressure should always be greater than vapor pressure. Okay, your suction pressure, okay, your suction pressure, okay, your suction pressure should always be greater than vapor pressure. So it gives us the idea that where we have to select a position 1, 2 or 3. Okay, while selecting this you have to calculate the NPSH. Okay, there is one condition also, fourth one. Okay, so this is technically not possible, but this is again better than the third one also. Why? Because this tank will have some potential energy. Okay, this tank will have some potential energy. So when the fluid is going downward, it will give you the free kinetic energy. It will give you the free kinetic energy. But see, again, this distance is the same. The amount which is coming below, it is going upward same. Okay, so that is why you should avoid this fourth one. Third one is the best one. Okay, third one is the best one for this case. Okay, but you can see that fourth one, if for tank is upward and you want to go somewhere, okay, okay, for this. So suppose if hs is below the ground, okay, suppose here hs is below the ground, then hs will be positive. Okay, then it is a positive thing for us. Okay, okay, so everyone got this. For this case the hs is 0. Okay, because it is parallel to your storage tank. So that is the condition of, that is the condition of submersible pump. That is the condition of submersible pump. Okay, so that is why they have a greater efficiency. Okay, so write this point. Write all these points. It means that if hs is increasing, npsh will decrease or increase. If hs is increasing, npsh will decrease. Okay, npsh will decrease. And what we want npsh should, what we want npsh should always increase. Okay, we want npsh should always increase. Okay, you can write all these points. Everybody done? Everyone has written all these points. Okay, so we have seen that if the npsh value is less, So means the pump will not have a good suction height. Okay, so we should have a npsh value should be greater always. Okay, so npsh is nothing but the calculating the efficiency of the pump at the inlet. Okay, npsh is nothing but calculating the, because if it is coming negative, it means that this pump means you have to change the strategy of your pump. Okay, so what you can do for increasing the npsh of your pump? Okay, if you see the formula is p suction by rho g minus pv by rho g. Okay, minus hs minus hfs. Okay, so what you can do the increasing the npsh. Okay, so you can see npsh is the calculating the efficiency of the pump at the inlet in terms of meter. Okay, so what you can do to improve the NPSH? Tell me. From the formula you can tell. Okay, you can visualize. Yeah, HS we can do it 0. Okay. Second thing, vapor pressure can be decreased. Okay, vapor pressure can be decreased. That PV value can be decreased. How can it be decreased? By decreasing the, okay, by decreasing the temperature of your fluid. Okay, by decreasing the temperature of your fluid, it means that for the cavitation to occur, this is most probably it will happen in the summer season. Okay, cavitation will occur most probably in the summer season, because at the summer season you suppose the water you are handling at a very high temperature, so there will be the chances of the cavitation. Okay, so hs can be 0, vapor pressure by decrease. Third, friction can be decreased. Okay, this HFS is nothing but friction. So this you will see in fluid mechanics in very detail. Friction can be decreased. So how friction can be decreased? By increasing the diameter of pipe. By increasing the diameter of the pipe. Okay, because when you increase the diameter of the pipe, friction will reduce. Okay, when we increase the diameter of the pipe, friction will reduce. Okay. Okay, so this you can write. These are the points improving NPSH. Yes, HS is nothing but Z. Okay, you can say it is Z value. So everyone is clear? Everyone is clear with this? So you have seen, means you have understood so many new points, I hope. Okay. Yes or no, write in the chat section fast. So almost there are 50 students. Okay, so I won't reply. But you are getting this all point, you are liking all this point or not. Okay, Okay, write all these point. Okay. Yeah, means basically bendings and all that will create a problem. Okay, so that pipe should be straight. Okay, Sushant Parikar. So you have known this point of 2.3 meter. You have studied somewhere. Okay, okay. Write all this point. Okay, that HS should be 0, or you can say it is 0, or you can reduce it. Temperature of your fluid should be reduced. Okay, and friction value can be reduced by increasing the diameter of the suction pipe. Okay, I have just written pipe. You can write here suction pipe, because we all the things I am telling it is on the basis of suction. Okay. So can we move forward? This 10.3 meter concept is very important. Okay. Means if you see in your college, then I think if 60 students are there, I'm sure that 59 students will don't know this concept. Okay, and this is very important. And this is not given in most of the books also. Okay, so I hope you have attended the fluid mechanics class in your college also, pump also. Okay, so you will not hurt this point, 10.3 meter. Even in my BTech, or for talking about myself, even I don't know in my BTech. Okay, after cracking the gate also I have don't know this point. Okay. Okay, now we have seen that there is a limitation of 10.3 meter. Then which is the pump which we are using in borewell or well? Okay, so because we have seen it is equals to 22.4 something. Okay, approx I am taking, and here we are dealing with the 50 feet. Okay, 50 feet, 100 feet, 150 feet. So which type of pump is this? So that type of pump is jet pump. Okay, so they have a special design, jet pump. Means back 10 years back, you can say in 2010 or 2005, that is the era of a jet pump. Okay, now that is replaced by a submersible pump. Okay, I will explain also that also how submersible pump works. So both are centrifugal pump work. Okay, so in our daily life, don't assume that we are using a positive displacement pump. Okay, because positive displacement pump is so much costly. Okay, because you will create a high pressure. Again, basically it will handle only very small amount of volume. Okay, the volume which the positive displacement pump handles, it is very small as compared to the centrifugal pump. Okay, centrifugal pump can handle a very large amount of volume, so that is the most positive thing for the centrifugal pump, and that is why we use it in the chemical industry. Okay, that is why we use it in the chemical industry. Okay, that you can write in. Okay, why we don't use positive displacement pump. The most important thing is it can't handle a large amount of fluid. Okay, because what will happen if it handles a large amount of fluid, the piston size will increase so much. Okay, so it means the piston size will increase, your cost will increase drastically. Okay, so that is why it means basically if you, it is just like that, you have a small syringe in your hand and you have a big syringe in your hand. Okay, So which one will be easier to give the dosing? Okay, to give the dosing, which one will be easier, smaller one or larger one? Okay, you can just imagine. Okay, so obviously the smaller one will be easier to give the dosing. Okay, so that is the point, that how we can handle a amount of fluid. So because industry we will be dealing with the most means we should handle a high quantity of volume. So that is why we will prefer, I'm not saying that 100% we are using centrifugal pump, we will prefer to use a centrifugal pump. Okay, everyone got this point? Everyone got this point, yes or no? Okay, fine. So now this screen is visible, that centrifugal pump is written. Okay. So wait, actually I have to, wait 1 minute, okay? There is an option of editing, okay? It's not coming. Okay, let it be. I will explain. Okay, I'm not able to draw anything on this diagram. There is an option, but it is not coming today. Okay, see it. See here. So this is a jet pump. Okay, this is a jet pump. Okay, wait 1 second. Wait, I will try to adjust. Okay, leave it. I'm unable to do the editing here. Okay, see here. The red arrow which is shown in the diagram, okay, the red arrow which is shown in the diagram, it is a centrifugal pump. Okay, when it is going upward, see here, it is bifurcated into two parts. Okay, one pipe is going upward and second pipe is again going in the downward section. Okay, see there. Okay, second pipe is again going in the downward section. So what is happening here, basically in the jet pump, there will be the two pipelines. Okay, there will be the two pipelines from the centrifugal pump. Okay, so 50% of fluid will go upward. Okay, and 50% of fluid again will go downward. Okay, see here junction. Okay, in this junction the 50% of fluid will go upward and the 50% of fluid will go downward. So what will happen, it will go, so that fluid have some potential energy. When it will going downward, it will again attain some kinetic energy and it will mix with the some amount of fluid. Okay, so I will try to explain from here. See here, so this is a pump. Okay, so here it is going upward and some fluid here it is mixing in this direction. Okay, the diagram is like this. So what is happening here, when the fluid is going, you can say some fluid is going in this direction and some fluid is going this direction. This is outlet. Okay, this is outlet of the pump and here it is a pump. Okay, and this is inlet. Okay, this is inlet. So means how many inlets are going downward? Two. This one is also going downward. Okay, and this pipe, okay, this pipe is also going in the downward. So this is a water source. Okay, this is a water source. Okay, so that is why if you closely observe your jet pumps, okay, that we are going to use 10 to 12 years back. So in some houses it is still available there. You can see in your house, if you are using a borewell and all that, there will be two pipes going inside in your borewell. Okay, there will be two pipes. Okay, in the tube well there will be the two pipes if it is a jet pump you are using. So what is happening here, some amount will flow from upper to downward. So at this point they have some potential energy. Okay, they have some potential energy. So when the fluid will coming downward, it will gain the kinetic energy. Okay, because by gravity it is coming downward, so it will mix with the main line. It will mix with the main line and some fluid, it will help to create some force there. Okay, because that how the fluid which is coming from top to bottom, it has a tremendous amount of energy. Okay, so that what it will do, it will give some energy to the fluid which is coming from the source. Okay, it will give some energy to the fluid which is coming to the source, means it will help that fluid to go in the upward direction. Okay, once it reaches the pump, it will go in the outlet. Again the cycle will continue. 50% will go in your source. Okay, and other will go into the your bottom of your pipeline. Okay, other will go into the bottom of your pipeline. So this is where jet pump works. So that is why the efficiency of jet pump is very less. Okay, so if you know that if you have a jet pump, it will take so much time. Okay, it will take so much time as compared to the submersible pump. Okay, as compared with the submersible pump, this pump will take so much time to fill a same amount of tank. Okay, why? Because it is taking only 50% of water outside the system. Okay, 50% is again always in the recirculation zone. Okay, 50% you can say approx, I'm saying. Okay, 50%, according to pump it will vary. So you can say better, you can say that some amount of water will go in your tank and some amount will be always recirculating in your pipe. Okay, some amount of water will always be recirculating in your pipe. Okay, so this is the thing the jet pump works. So this is the working of jet pump. Okay, so now again I will share the diagram. You can see that. Okay, so this is the diagram. Here you can see that. See, some fluid is going upward and some is coming back to the bottom. Okay, so that will create a tremendous amount of energy that fluid have, and it will help to suck water from the water source. Okay, so this will help in the borewell and tube well. So back to 10 to 10 years back, okay, we have used so many jet pumps for this. Okay, so this is the way. So here what is the limitation of that? 10.2 meter. So to remove the limitation, what we have done, some amount of water is always in the recirculation mode. Okay, to remove our limitation of 10.2 meter, we have some water always in the recirculation mode. Okay, so everyone got this point, or you can write this point also, jet pump. So everyone got this point, yes or no? Yeah, you can use submersible pump in borewell. Okay, yeah, jet pump is a centrifugal pump. Motor is same, the impeller will be there, centrifugal force will be there, all will be same. Okay, what happens, we recycle because the water which is at the top, it has when it is coming to the bottom, it has a tremendous amount of kinetic energy. Okay, so what will happen when it is mixed with the main pipeline? It gives energy to the system. Okay, it gives energy to the system, and that helps to suck the water up to a larger suction height. Okay, that is greater than 10.5. Okay, so that is the benefit, but again there is a drawback. Okay, drawback is that you need a more amount of energy. Okay, your electrical energy will be more, so that is why if you are using a jet pump, the electric bill will be more. Okay, it will consume more energy because you are getting only some amount of water at the outside. Okay, every time the some recirculation is going, and at the outlet you are getting some amount of water. Okay, why we are doing this? Just to remove our limitation of 10.2 meter. Okay, so you can write this. Everyone got this point? Yes, Samitwa. Apurva, I'm not getting your question. Tube well operate on? What is the tube well? Hand pump you all want to say? Yeah, hand pump is manual, na? So that is a reciprocating pump. Okay, hand pump is a reciprocating. Okay, hand pump is a reciprocating pump. It is not a pump actually. The operation is like a reciprocating. Okay. Okay, so the jet pump can be used up to 50 meter, 100 meter, or sorry, 100 feet. Okay. Irrigation's electrical cost decreases if inlet pressure is high, but that saving cost is too low and negligible because we get only small amount of quantity. Okay, yes. Submersible pump also you can use it up to 50 feet, 100 feet, 150 feet. Okay, and before starting the jet pump, you can't start it directly. Okay, you have to fill that both pipes. Okay, you have to fill the both pipe initially with the water. Okay, only then it will work. You can't just put it down and start your motor. Okay, you have to fill this with the water. Just write all the points regarding this. Then I will explain the submersible pump. Okay, write the points. Write the points, okay, how it is used. We will see, Anurag, which one is costly. Just write the points. I'm giving 1 minute, okay? Then I will explain submersible pump. Okay. We will now go towards the submersible pump. Okay. Submersible pump. So submersible pump is nothing but it is also one type of centrifugal pump, but with a leak proof casing. Okay, that casing will costly here. Okay, the cost of casing will be costly, but it will have a greater efficiency. Okay, it will have a greater efficiency due to 2 3 points that we are going to see. So centrifugal this submersible pump you can see, which is now it is used in the cooler also. Okay, if you have seen the old cooler, the pump is far more away from the water. Okay, now if you see the pump which you use in your cooler, it is deep inside the water. Okay, so that is a submersible pump. You can say that is a small submersible pump. Okay, so it is most frequently used in the tube well and well. The most important point is here Hs equals to 0. Okay, because it is placed inside the water. It is placed inside the water. Okay, so I told that the pump will work better when it will push the liquid. Okay, the pump will not work better when it will pull the liquid. Okay, we have seen that when centrifugal pump there are limitation of 10.3 meter in pulling, there is no limitation in pushing. Okay, so when you see the submersible pump, the pulling is 0, it has to only push. Okay, it has only push the water. Okay, the pulling is 0. Okay, so that is why the submersible pump have a higher efficiency. It is costlier, no doubt. It is costlier than the jet pump. The reason why it is costlier than the jet pump, okay, the reason why there was a costlier than the jet pump, because you have to make a leak proof casing. Okay, that casing should be leak proof. Okay, because you have electrical wires in that and all that should be leak. Okay, that should not be any proper casing should be provided in that. Okay, so what is happening in the this submersible pump? If you are using it for a tube well and that, they are nothing but a pump in series. Okay, they will act not exactly the pump, there are different pumps. Okay, but it will act like a pumps in series. So they have a diffuser in that. Okay, they have diffuser. So what that diffuser will do, what the diffuser do, when the pump is, when they suppose this is your shaft and when the pump is rotating, once the fluid will move from one diffuser, what it will do, it will increase your velocity. Okay, it will increase, the velocity will increase. Okay, but what diffuser will do, it will do the velocity equals to 0. When velocity equals to 0, your pressure is going to increase. Okay, your pressure is going to increase. So you have 3 to 4 diffuser in that. Okay, when it will go from one to second diffuser, what it will do? Again, velocity will zero, pressure will increase. Velocity zero, pressure will increase. Velocity equals to zero, pressure will increase. It will increase your pressure up to certain point. Okay, it will increase your pressure up to certain point. After that, it will reach your destination. Okay, it will reach your destination, that is delivery point. Okay, that is delivery point. So what is the use of diffuser here? diffuser. It will do velocity equals to zero. Ultimately, when velocity equals to zero, pressure is going to increase. Okay, that is from Bernoulli's equation. Okay, when velocity equals to zero, pressure is going to increase. So reverse is when velocity will increase, pressure will decrease. Okay, reverse is that when velocity will increase, pressure will decrease. So this is going to happen in the submersible pump. Okay, this is going to happen in the submersible pump. So in the submersible pump, that pump, suppose this is your tube well. Okay, of 100 feet. Okay, so your pump will be here. Okay, your pump will be like this in mostly in vertical position. Okay, so here it will be deep inside the water. Okay, as it is deep inside the water, automatically there is no limitation of 10.3 meter. The limitation is removed. Okay, because now HS is zero. HS is zero, you don't have to worry about that thing. Okay, you don't have to worry about that thing. Okay, HS is nothing but calculating the efficiency of your pump. Okay, HS is nothing but the calculation. Means up to what height you can place a pump. Okay, up to what height. And NPSH is nothing but the efficiency. NPSH is nothing but the efficiency of the pump. Numericals and all that you will be seeing in fluid mechanics. Okay, all numericals will be there. Okay, sir, how the electric current will be sent? That's I told na. You have to do a proper casing. Okay, you have to do a proper casing of the electric wires. Okay, so that you can see in cooler also. Okay, now it is mostly used in most of the coolers. Means all if you purchase a new cooler, it will be definitely will have a submersible pump. Okay. Yes, Sushant. Okay. So everyone got this point of this. Everyone got this point of submersible pump, jet pump, centrifugal pump. Okay. So can we move forward? Just write down these points. Okay. It will not, it is not directly written in the books. Okay. These all points. So please write down all these points. I'm giving you 2 minutes. Write down all the points. Pump is fixed. Okay. Pump is fixed. Everyone has written points. Everyone has written the points. Yes, I means if your water level is changing, then obviously you have to move the pump. Okay, means we will not move the pump frequently. Means after half an hour you will move the pump. After 10 minutes you will move the pump. If water level is changing at that time, we sometime we move the pump. Okay. So if you see all these points, okay, if you see all these points, we are using this. Okay, we are using all these points basically for the liquids. Okay, suppose if I want to flow gas from the reciprocating pump. Okay, suppose I want a gas should be flowed from reciprocating pump. So can I do this? Gas in the reciprocating pump, or you can say positive displacement. Okay, gas from positive displacement pump, PD pump. Can I do? Can I do or no? Just think. Just think. Okay, I'm giving you 1 minute. These all are interview questions. Okay. So the answer is no, you can't directly move the gas from the positive displacement pump. Why? Because what will happen? Gas will compress, na? Liquid will not compress. Liquids are incompressible. So that is why you can move the liquid from the positive displacement pump. But gas will compress. It will not move. It will compress in your section. Okay. So what you have to do first, you have to convert them. First, you have to liquefy the gas. First, you have to liquefy the gas, then you can use the PD pump. Or what we do? Compressors. What we do? We use compressors. Okay, so you have seen when you fill the air in your vehicles or in your cycle, there are compressors like this. Okay, so what they do exactly? They will compress your air. Okay, they will just compress your air. So at the outlet, when it will release, the motor will start again compressing that. Okay, so you can't directly use gas in the positive displacement pump. Okay, you can't use gas directly in the positive displacement pump. Why? Because gases are compressible. Okay, so that is why gas will compress. So once it compressed, how it will move? Okay, so that is why we can't use gas directly in the positive displacement pump. First we have to liquefy the gases. Okay, we have to convert them into the liquid, and then we can move that. Okay, so again this is an interview question, you can write that. Okay, so for the moment we use mostly the compressors. Okay. Okay, everyone got the point? So please write these points, okay? Make your notes proper in this. I'm giving you time. Okay, so tomorrow I will give you all the points. Okay, those you have written, it's okay. Tomorrow I will give you the points at the starting of the lecture. Okay, because tomorrow's lecture will be the last lecture. Tomorrow I will be talking about general questions which they ask you in the interviews. Okay, and some part of the no, this is my last subject. Okay, so tomorrow will be our last meeting. Okay, so those who are going to give gate in 2000, I think 20, this is 21, na? Yeah, those who are going to give gate in 2022. So for them, I can come again. But those who are going to give you gate 2021, so tomorrow will be our last meeting. Okay. Okay, so tomorrow you can give me the feedback actually also. Okay. So basically, I have told in the yesterday lecture one point is that constant head pump. Okay. Centrifugal pumps are known as constant head pump. So there are three characteristics curves actually. Okay. Head versus flow rate. Okay. So it will be like this. Real, it will be like this. But sorry, this is ideal case and real. Means when the flow rate will increase, okay, when the flow rate will increase, your height will decrease. Okay. Your height will decrease. Okay. So there are actually 2 points actually. Okay, there are 2 points. Suppose this and I can draw this with black line itself. This point. So at this point, Q equals to 0. Okay, wait. Q equals to 0 and H equals to, what is H here? Okay, Q equals to 0 and H you can say any number. Okay, any infinite number you can take, or you can say maximum. Yeah, you can use word the maximum. Okay, so Q equals to 0 and H equals to H max. Okay, that point is known as, okay, shut off head. That point is known as shut off head. Head means up to what head you can deliver the water. Okay, here head means up to what head you can deliver the water. So Q equals to 0, H equals to H max. This is known as shut off head. And when Q equals to Q max and H equals to 0, okay, H equals to 0 means this point, okay, this is known as free delivery. This is known as free delivery. And both this point, the efficiency of pump is, at both this point, the efficiency of pump is 0. So this is the most frequent question they ask you in the interview. At what 2 points the efficiency of the centrifugal pump will be 0? Okay. So when Q equals to 0, H equals to H max, that is known as shut off head. And when Q equals to Q max and H equals to 0, it is known as free delivery. And the efficiency of the pump is 0. Okay, efficiency of the pump is 0. So what it gives us the idea that our pump will be lying in between these 2 points. Okay, our pump efficiency will be lying in between these 2 points. Okay, in between these 2 points. Okay, our pump will be lying in between these 2 points. So where it will be lying, it depends upon the characteristics curves of the pump. Okay, where it will be lying, it depends upon the characteristics of the pump, that we are going to see in tomorrow's lecture. Okay, where it will be lying, it depends upon the characteristics of the pump. So basically the graph will be like this. Okay, height graph will be like this, pump will be like this, efficiency will be like this. So at this point the efficiency will be maximum. So for this efficiency, your head is fixed, your Q is fixed, your power is fixed. Okay, these three parameters are fixed, and that is why it is known as, your head is fixed for their maximum efficiency point. That is why it is known as constant head pump. So this point we are going to see in detail tomorrow. Okay, this point, which is very important, constant head pump. Okay, so this curve we are going to see tomorrow. That is, what is the meaning of constant head pump. Okay, so this is the last point which I will take in the pump. Okay, almost I have taken most of the pump. Okay, so actually I have skipped some Bernoulli's derivations in the pump, but as you don't know the Bernoulli's equation, so that is why. Okay, so that you will do in the fluid mechanics also actually. Okay, so what we have seen, okay, what we have seen, the most important points in the centrifugal pumps is are, first one is your suction pressure should be greater than vapor pressure. What is HS? HS should be 0. Okay, it means NPSH will be maximum. Third, NPSH available should always be greater than NPSH required. Okay, fourth one we have seen, what is jet pump. Fifth, we have seen the limitation of 10.3 meter of H2O. Okay, sixth, we have seen what is submersible pump. Okay, so these points we have covered today. So these are very important. Okay, all the 6 points. Okay, the last point is remaining, that is the BEP, that is best efficiency point. Okay, so that is we are going to see in the tomorrow's lecture. Okay, next subject after PD, that I don't know. Okay, now you can ask the doubt. NPSH I told na, NPSH depends upon suction pressure, second vapor pressure, third HS value, fourth friction. Okay, these value. Samitva, that is also a part, okay, but that I'm not going to take, okay. That is very much important for the actually turbines, okay. NPSH required, okay. This is all the points about the available, okay. NPSH required is the value which is given by the company. So they don't consider the HFS value. Okay, they don't consider the HFS value. Okay, because for them there is no friction. Okay. Okay. Anyone other doubt? You can't directly pump gas, Rohit Sharma. Okay, you can't directly pump that. No, tomorrow timing will be same. Okay, 6 to 8. Yeah, means mostly theory questions are asked in gate. Okay, and from the last 11 years, there is no question from the gate designing. Okay, 9 or 11 years. Yeah, compressors I will tell you. Okay, I will give you short note on compressors. No, that will be compressed in the cylinders, Rohit Sharma. That will be compressed in the cylinders, or you have to liquefy them. Okay, or you have to liquefy them. Okay, Rohit. Anyone has any other doubt? Yeah, gas cylinders. Sayak, basically what will happen in that required point, okay, they will not consider the friction, they will not consider the HS value, but what they consider is that up to what height the pump will work. Only that point they will be considering. Okay, and the water they will be using will be pure water. Okay, so means no dirty water is that, so whatever will be friction will be there. So available will be greater by increasing the diameter of the pipe. That's why I told na, they have not mentioned the which diameter of the pipe you are using. Okay, that is the point. Okay, they have not told the at what temperature they are doing that. Okay, 21151, a difference between tubes and pipe, this you will see in fluid mechanics. Okay. Okay. Thank you then. Good night.